Yeah.
Twisted arm up the back.
Paddy,
All
I've
yours,
got in
mate.
touch with, he's not well. In fact, he's quite poor, to be honest.
So, thanks for coming, and my name's Robert, M0NVQ, and just wanted to talk about my messing about with QRP antennas and the frustrations I had, and eventually the successes I had. So last week I talked about the Wheatstone Bridge. I was concerned that QRP transceivers didn't have protection on the transmitter side, so you could short the transmitter and blow it up, which I actually did on one occasion, and had to replace the FET output. So it's, I thought it was important to protect, so I built the Wheatstone Bridge, which I talked about last week, and that stood me good for what I want to talk about this week, which is the Fuchs, that's German F-U-C-H, Fuchs Kreuz, or Fuchs circuit antenna. So I got a lot of background noise at home. Solar panels, next door neighbour's got a plasma TV. Background noise is horrendous.
Lucky you.
And there's not a lot I could do about it. People suggested turning them off appliances in my house, so I just turned the mains off, and it didn't make any difference. I tried the NorCal doublet at the time when I just got me. When I got my licence, it was popular in Facebook and whatnot to look at the NorCal doublet. That was very noisy. I tried an inverted V dipole, which was very noisy. I tried the inverted V with the balun on the top, choke balun, to choke off the outside of the coax. That improved things a little bit, but it wasn't brilliant. And when I went out into the country, I showed this last week, just a lightweight dipole. In the countryside, near Stanage Tunnel, the noise was virtually zero, and that worked really well. But the coax bends the fishing pole, so I wanted to try something else, and I did try a random wire. So this is a non-resonant wire, not the half wavelength. And I tried that. I thought, well, I'll try it at home in the garden and then take it out in the country. And so I used the GQRP Club's Z-Match matching unit and a 4-to-1 transformer. And I couldn't get a consistent match with the limited counterpoises that I put on the back garden. And I thought, if I take this out in the country, it'll just take too long. My sort of mental target was to have an antenna I could set up in 15 minutes in the National Trust or somewhere in the countryside or on the canal banks side. And that was my target, to have an antenna that I could set up in 15 minutes. People said, oh, you could use an antenna at home and run an earth to ground. And then I mentioned Alan Moss, G4VBT, I slightly passed, but he pointed out a 5-metre long earth lead from the front bedroom in the house to the garden would be a quarter wavelength long on 20 metres, and therefore would be low impedance at the radio, infinite impedance at the ground, so the counterpoises would see an infinite impedance and it would make no difference. So I did start to think I'll never get on HF at home. That's what I honestly thought. I thought, well, I'll stick on 2 metres and 77s at home and stick on the dipole on the countryside. And then I came across the Zeppelin antenna, and that's where I got to the Fuchs antenna, which does work. For me, it worked. So I'm not saying that that's the perfect antenna for everybody, but it was an interesting path that a lot of other people had walked. So this is 1900. There was Zeppelin antenna, which they hung from Zeppelin.
Yeah, really.
So it's two 1/2 wavelength long wires fed by a quarter wave ladder line hung from the bottom of a Zeppelin. If you use a half wave dipole, so it's half wave long, 2 quarter waves, it's directional. It looks like a donut with a knitting needle through it. But if you use 2 half wavelength wires on the ladder line, it's slightly more, well actually quite significantly more directional. It's like a dinner plate with a knitting needle through it. And instead of We normally consider a dipole to have a gain of 2.2 dBi. That's a gain of 2.2 over an intrinsic point, which technically doesn't exist, but that's how. And so this antenna has a 3.8 dBi gain, or it's a gain of 1.6 over the dipole, because the field is squeezed in. It's quite directional. So they're like that on the Zeppelins, but both ends have to be supported. When it rains, the water runs down the ropes. You have to bear in mind this is in an age where they didn't have plastic. And it's a quarter wave feed line, low impedance here, high impedance there. So it's high voltage there and high voltage there, where the two routes are. And it can spark up. And they're in a hydrogen balloon bag. So, in 1909, Hans Degerow was awarded a patent for having a dipole. This is what we know as the Zeppelin now, with just a single half-wave wire hanging from it. So you've got quarter wavelength ladder line, low impedance at the transmitter, high impedance at the end, matches into the half wavelength long wire. Unfortunately, it only has a gain of a dipole, so it's got no gain over a dipole. But you don't actually have to have a rope to support the end. A lot of the airmen on Zeppelins were sailors, and they would, in the ship, use a sea anchor, which is, you know, if a ship loses its engines or its masts, it can skate across the water at the speed of the hurricane. If you drop a sea anchor into the sea, like a basket, it slows the ship down. So first of all, I put baskets on the end, so the Zeppelin's going forward, and the rope out horizontal now with a basket on it. If they had nylon, then they would put a windsock on from, like you see at an airport. And they did try kites. Well, they successfully used kites to keep the wire horizontal. With no rope at this end, it doesn't spark to the hydrogen balloon. So it's a great antenna and it works. And the other way up is what we know in our books as the Zeppelin antenna. So if you've got 40 metre band, half wavelength is 20 metres, quarter wavelength is 10 metres, you've got a 10 metre pole and a 20 metre wire, you've got a Zeppelin aerial, a Zeppelin antenna, which is great. But the only problem with it is, it works on one frequency. And you can take it all down and change the length of the wire to change the frequency, but you've also got to change the ladder line, because the ladder line is a transformer. It's transforming from low impedance at your transmitter to high impedance at the end of
Excuse
the wire.
me, when you say it works on one frequency, do you mean one band?
No, well, it's tuned to one frequency. I mean, when you go off frequency a bit,
Yeah.
you get a higher SWR.
Right, yeah.
But with this configuration, that's a quarter wavelength and that's half a wavelength. So you go to another wavelength at the other end of the band or something. You've got to trim a bit off here and you've got to trim a bit off there.
Yeah.
Bit of a nightmare. And then, this is where we get very much to the Fuchs circuit. In 1936, W3EDP came up with the idea of using a transformer instead of the feed line. He replaced the feed line with a transformer. So the ladder line was working as an impedance transformer, and now he's using a transformer to change the impedance here, which is nearly infinite, to 50 ohms to suit your radio. With a wire antenna, an end-fed half-wave, the end impedance with the wire that like SOTA beams sell is about 3,200 ohms. There's a radio ham, and unfortunately I didn't keep his call sign, there's a radio ham on Facebook who used to work on the Pop Pirates. He was a qualified radio, BTEC HND radio engineer, and he was talking about end-feds, and he said if it's because the impedance is related to the diameter of the antenna, an 8-inch diameter mast on Radio Caroline and Radio North Sea had an end-fed impedance of 600 ohms. but for a wire it's 3,200. So if you've got a transformer with a ratio of 8 to 1, which is an impedance transformation of 64 to 1, just works, the maths just works out without even having to take your socks off to count. It converts 3,200 ohms to 50 ohms. So, a great circuit. On this circuit, the other side of the ladder line works as the counterpoise. Obviously, with a dipole, you need two halves, just like a bird needs two wings. So you've got the long wire, which is the radiating element, but the transformer line, which is quarter wavelength long, the other side of the ladder actually is the counterpoise. So on this circuit with the tuned circuit, it's a parallel tuned circuit, so it goes to high impedance on the resonant, you tune the tuned circuit so that it goes to high impedance on the resonant frequency of your wire. So if you're on 20 metres, the wire is 10 metres long, and you tune the tuned circuit to be high impedance on 14 megahertz. Tuning the tuned circuit doesn't change the length of the wire, but it does match the wire to your radio if the wire's the right length. What else was I going to say? Yeah, adjusting the parallel tuned circuit is analogous to changing the length of the ladder line, but it doesn't change the length of the ladder line. It doesn't change the length of the wire. And if you would like to build one of these, there's an excellent website. It's M0UKD.
Yeah.
His website is absolutely brilliant, and he shows one of these circuits, and you put the counterpoise on the other side. So I copied his design, well, pretty much exactly. If you look at the picture on his website, it's the same as mine basically. It's an air-spaced transformer, 8 turns to 2 turns. The wires are kept apart because there is a potential high voltage there, and there's a variable capacitor to tune it. That goes to the radio, that tunes it, and that goes to the antenna. Now, yes, so this does work. So I went, we were going to celebrate my birthday in 2020 in September, and they didn't lift the COVID restrictions. So in October we went to a cottage at Fountains Abbey, and there was next to no background noise, there was no buck converters working, no solar panels. So I set up the rig with this antenna. I had a 4 metre high SOTA beams pole and then a 10 metre high SOTA beams pole, and I put up 20 metres of wire, and then I put a counterpoise on perpendicular to it. They're not perpendicular, in line with it, and it would tune on 40, 20 and 10 and 15, and I got QSOs on sideband on 40 and 20. I got to Toulouse on 5 watts, just random. The guy was there and we both gave each other 5 and 9. He was strong. So this circuit works an absolute cracker. It's a bit big, but it does work, and if you look at M0UKD's, I copied his design and I just tried to make it the same as his. I made the same mistake as other people did. I tried to mount the transformer on Veraboard. You mount the transformer on Veraboard, you go for a cup of coffee, you come back, and the strength of the spring pulls the tracks off. And then I googled it, and someone else has had exactly on Facebook. Someone else has had the same issue. So I've used the solder tag strip thingamajigs that Tony Cavanagh, TK Electronics, sells at the rallies, and I stuck it on a bit of plastic, and that's super glued on the case. And because copper wire, when it seems to relax, it seems to have a strength. But anyway, that worked an absolute treat. So I need to tell you something about this circuit, in that it works when the radiating element and the counterpoise are in line, and they must not be electrically coupled to each other, capacitively coupled to each other. And the circuit works with a short counterpoise, and this has stirred some debate, because you would have thought it should be a quarter wave counterpoise, like as in the ladder line, and then a half wave radiating element. But providing these aren't coupled, It will work with a counterpoise that is a tenth of the half. So if you want to go on 40 metre band, you've got a 20 metre wire, and you've got a 2 metre counterpoise, and it works. So I was really pleased with that. There's some debate about the short counterpoise, and Moxon, so you know Moxon Yagis, he suggested that the circuit wasn't a half wave and a 20th wave. He suggested that people were actually measuring the wire incorrectly and it was longer than you thought. He proposed that there's a 20th there, a 20th there, and then the half wave. Well, that's something, an idea he mooted, and then people pointed out that if those are 2 20ths of a wavelength, it's a J-pole. And on a J-pole, or a Slim Jim, the 2 short counterpoises are electrically coupled. They're adjacent to each other because you use the ribbon. Whereas in this circuit, that wire and that wire must not be capacitively coupled. So the Moxon idea, explanation for why you only need a short counterpoise, was sort of dismissed. DC4KU came up with this very, very slightly different variation. Still the same tune circuit, still the same half wave, but he proposed you could get rid of the counterpoise completely if you use a coax, which is a minimum of a tenth of the half wave, and put a choke on it. So it's like the coax choked dipole. You know, you have for 2 metre band, you've got half a metre out of the core of coax showing, and half a metre of the coax outer showing, and then you choke it off so it's 2 quarter waves. Pete Singleton uses an antenna like that, and this is similar, that you choke it off at a tenth of the half wave, and you don't need that choke there, and that was his circuit, and that works. And that's slightly similar from, you know, the end-fed half waves that you can buy on eBay that aren't tunable. Those have a long coax feed on them that's a quarter wavelength long. Whereas this circuit with the tuner, you can get away with a tenth of the half wavelength. And then we're nearly there now, DL7AB in 1949, he did a slight variation on this circuit, and he described it as a multi-band end-fed. So you've still got the tenth of the half wave as the counterpoise. Then you have this is 40 metre. This is extending the antenna that you would use on the 40 metre band. So you've got 20 metres there, which is half wavelength for the 20 metres, and then you put a 110 microhenry coil on and 2 metres of wire. So that's a trap. At high frequencies, that's a trap. So the circuit just looks like a 20 metre wire, which would be half wavelength on 40 metre band, so on. So I have to work those out. But the choke and the 2 metres on the end make the wire look as if it's 40 metres long on the 80 metre band. So that's how I could hear your Morse on the 80 metre band. And you'll find this antenna mentioned on Facebook and on eBay, and people like UK Antennas sell I haven't got a facility to measure impedance, inductance I should say, so you can buy them off the shelf for 110 microhenry coil, which has capacitance between the turns, so it's an inductor in parallel with a capacitor, so it's a trap. So it traps off the end of the wire on the shorter wavelength bands, and on the 80 metre band it's a loading coil. And that does match on all the bands. So that works a treat. That's how I can hear. I've taken it's here, so it's not at home, but if it was on the end of the wire, I can hear 80 metres. It doesn't stop 80 metres from being noisy and virtually impossible to use on CW. But
Nothing does.
And then
They're living in a field.
yeah, or National Trust car park.
Yeah.
So that basically brings us to the Fuchs circuit. So this is the same circuit which you'll recognise. It's got the parallel tuned coil, parallel tuned circuit and a low turns primary. And this has got a low turns primary, you've got your coil and you've got your capacitor. But what the German QRP project did was he added a series inductance in series with the antenna. So this circuit works. One thing I would say is they had problems with the kit. They sold a kit and the switches that they were going to use, because these have got a 6-way switch and a 4-way switch, they became unavailable. That they provided another set of switches and you couldn't get all the bits in the box. And then they stopped selling the kit, which is probably because you can't physically get all the bits into the plastic enclosure that they sold. But if you go on the website, all the instructions to build it are there, and in fairness, it does say in the instructions you don't have to buy the kit, you can make it yourself. So lots of people have done that, including myself. So you start off with the switch at one end, tuning on receive first, start at the switch at the one end, whiz through the capacitance, move the switch, the loading up then move up the transformer again, change the switch here and move until you eventually find the sweet spots. It can take a few minutes, which is why I use the stickers of a calendar to mark the sweet spots. And I've got a piece of paper which I normally never let out my sight, and I've lost it. So, oh, here it is. So I know for the 80 metre, when I've got the coil on for the 80 metre band, switch 1 is in, the 4-way switch is in position 2 and the 6-way position is in 6. And I tune the variable capacitor to the orange dot. And that's a good guess, and then I can just tune it, fine tune it to get the SWR down. And it does work on, it does tune up on 10, 15, 20, 40 and 80. If you've got the coil on with the extended wire, it will tune on all those bands, because they have multiples of the half-wave. Right? So there's another little nuance of the circuit. So there's the circuit, it all fits in the box. I bought at the Norbrec, at the NASA Rally, I bought a Nano VNA, the vertical network analyzer, the H4. And I found with the antenna in there, so I use a banana plug on the antenna so that if ever the aerial decided to go, it would just pull out. And just with this amount of connector on, RG213 into the nano or into my radio, I'm getting an SWR of 1.09 on 20 metres. And it matches up, and that's all the counterpoise there is, and it matches up. But and there's loads of people building these, but don't try and get the kit, you'll never get it all in the box. The kit comes with a polyvar variable capacitor, which are for medium wave kitchen radios basically, the polyvar. The little, you know what I mean, little radio with a PP3 in it. The polyvar capacitors aren't designed to withstand a high voltage. So don't be surprised if you use a polyvar that it breaks down. I'll just explain why, because it's useful to think it out. Power is voltage times current, so power is V squared over R. With an 817 you're putting 5 watts into 3,200 ohms, so V squared is 16,000. So the VRMS is 126 volts. That's VRMS if it was like a power supply that you were designing. So the half peak, you have to think about the half peak, it's times 1.4, and then you're going peak to peak, comes out about 400 volts. So a polyvar will possibly stand it, but mine didn't, so I just got this squealing noise. You can't see it breaking over, even if you turn the lights out doing darkness, but you can hear it. If you're running at 10 watts into 3,200 ohms, the peak to peak is 506 volts. And if you're running 20 watts, the peak to peak is 715 volts. So it's more of a QRP antenna matching unit. probably not go over 10 watts anyway, for sure. But that's why you should use an airspace cap. But there's lots of airspace caps at the rallies, because someone's dismantling valve radios and taking out the 15 picofarad to 365 out. So you can get them. Like the one, I've got two of these. I've got one running in the house at the moment with a whisper station on it, and that cap has to cost me a fiver at the hack bunker in Nantwich. That one, I think that one cost. Oh, that one cost me a fiver as well because the price is still on it. So but the circuit works. The circuit works. I did try using this one with the counterpoise at the house, and I just could not find a way of putting the counterpoise in the antenna so that they didn't couple. But with this circuit, because it basically doesn't use a counterpoise, I've got the wire. I've got Sota Beams' wire out the window frame to a tree, and then back along the side of the house to a mast I made out of drain pipe, and then I can take the end down and put that on and stick it back up again if I want to go on the 80. But it all works. So I don't know if that helps anybody, but certainly that antenna's a way of getting on 80 if you can't get enough wire up.
Yeah.
So with that, can you receive top band as well?
No.
You can't even receive top band, no?
Can't receive top band because the half wavelength is 80 metres.
Right.
And the house is nice, but the garden, you can spit across it, so I just can't get enough wire up in the air. As it is, the wire I've got up at the moment's got a dog leg in it. Right. So now I can't get onto top band.
Well, even getting 80 is pretty good, isn't it?
Yeah. I mean,
smaller plot.
I could hear both operators from the other. I live in Oldham. I can hear both operators from the other club, and they couldn't hear each other. So I was doing something right with the antenna.
Yeah.
So how high you got it?
So I've got double glazing window, and I've got the wire 2/3 of the way up of the double glazing window. I put a plastic thing tied on the wire, goes out the window so it doesn't, and then it goes up to the gutter of the house, where I've got a hook, and then it runs into a cherry tree that's at the same height. Then it runs from the cherry tree to a pole by my shed, which is slightly lower. It's about 8 metres high. It's not that high, I could get it higher.
It's just about 16 feet, isn't it?
Yeah, considering it's not that high, to get picked up with Morses on an 80 metres is quite good.
So, on 20 metres, which is much quieter, I can hear, I think it's south of France, the Eastern Bloc countries, and the Scandi countries, you can hear them. And I've got the Hans Summers QRP, his little sideband, the CW transceiver, which decodes the Morse for you, and I've also got the app on my phone. So some of them are just too fast, but I can see I'm getting a distance. And when I'm running running Whisper into this at 4 watts, I'm going completely around the world. So that's Anchorage in Alaska, Australia, New Zealand. The German Antarctic station's got a German amateur radio operator on it, and the ice-breaking supply ship that goes between South Africa and Chile and the German Antarctic station, that's got a radio amateur on it with a Whisper, a skimmer on it, and I'm hitting them. So I've had the best results on Whisper using one of these boxes.
So how, can I just ask, how is your house at ASL then?
I think it's about 160.
Is that all? It surprised me,
The Oldham's not that high.
yeah. No.
I've got
good, that.
Yeah, because I'm 300 feet above it.
Yeah, 200 feet where we
I'm
are.
300 feet above land, about 320.
what's 160 metres in?
Oh, you said 160, it's metres you've talked?
Yes.
Oh, so you're 500 feet in that,
Yeah. But
Well, it's not the older way, aren't it? It's higher.
yeah.
I thought it said it's 160 feet. Yeah, no, it's 160 metres is 500 feet.
Yeah, some strange things happen at night on 20 metres in that sometimes, if you use the Whisper software, sometimes I get Antarctica in the middle of the night in darkness, which must be that residual ionisation effect that I read about. but it's long. It's the 1 minute 51 seconds long. That's how long the whisper blocks are. So it must exist for just long enough for me call signing to.
Yeah.
So, but this all works, and it is a way of getting on HF if you got an M6 license, you can build an antenna. You don't have to build. You can't build a transceiver, but you can build the antenna. You can use a Wheatstone bridge to protect your antenna while you protect your radio while you're messing about. And then you can use, because I have used this, or used that one, in a field. And my intention is to use this one in a field, away from the house, because the inverted V dipole did not bend the pole. And I just could not get a non-resonant end-fed wire to match, because I couldn't put enough counterpoises out. You know, you spend 8. What I did was I bought, you know, the dog screws that they sell at Pets for.
Into the ground.
Yeah. I've got a dog screw and I put a small Jubilee clip on the top with a copper tag on it, which I put on loads of counterpoises, 1 metre, 2 metres, 3 metres long, the back gardens maybe, and with tent pegs on the ends. And I put it out as a fan, and it still wouldn't tame the non-resonant end fed. It was just, I couldn't get a consistently low SWR at the base of the antenna and at the radio at the same time. I thought, well, this is never going to work if I take it in the field, is it? Because A, people are going to trip over it, and B, you just can't use it in tune frequencies. So. But this works, and it's just rather strange. But then a Zeppelin, when it's at 10,000 feet, they haven't got an earth either, have they? So.
No.
You've got quite a height, though.
They've got quite a height. 10,000 feet, the horizon's 115 miles away, I think. There's a calculator on the web. So. But then you would expect it to be reflected as well, wouldn't you? I'm sure.
Yeah.
So I don't know whether that was any help, but what I want to do is perhaps the next step is take my nano VNA out to tune that on a frequency with a pole in a garden somewhere. I've tried this one in the countryside and it works a treat. My next step is to try that because it's smaller.
So how much antenna would you need for that?
Half wavelength.
Right.
So for 40 metres you need 20 metres.
Yeah.
For 80 metres you need 20 metres and the coil and another 2 metres. But 40 metre band, 20 metres of wire, you could get that diagonally up to, well I did do it, I used a 7 metre pole and a 10 metre pole around the wire. If I just wanted to use 20, which is quiet, that nice quiet band with lots of people on it, then you need 10 metres of wire and I've got 10 metre long poles. So.
Right.
So getting on 80 metres for 22 metres of wire,
Yes.
basically.
Which is less than I use 20 meters,
Yeah.
as we do. 8 and 6. 8 and 12 don't we?
8 and 12, which is 20, it's only another 2 metres, isn't it?
Well, we actually, yeah, although we've got 20 metres, the actual distance is only 17 metres.
Yeah.
You could put loading coil on the end and make it longer.
Well this is a loading coil, but it goes on the remote end, not on the
Yeah.
radio end.
Yeah.
So this company is ukantennas.co.uk. I'm not on a commission or anything, but it's ukantennas.co.uk. And I'm pretty sure that was 49 quid because I was too lazy to build one. There are people that... so obviously it's got the terminals on the end and you put crimp on or solder on eyelets on the end to do it. And then wind it up with tape and try and keep the rain out. So there are people that have worked out, and if you Google it, you'll find there are people that have measured out the length of wire so that when they got 20.5 metres and then wound this
Yeah.
and taped it off without any breaks in the wire to let the rain in, and then they've got 2 metres left at the end. And then they found somewhere measuring the inductance by making a second coil, which they then scrap, which they measure the inductance on. And that's how they then have that in their go bag, and then there's no worry of the rain getting into it. I used self-amalgamated it, which I don't like because it's not reliable, but that's what I had. But yeah, you can get on 80 metres with 22 metres of wire.
That's pretty good, that.
Anyway, that's about all I know. So.
That's
Someone
very
else-
interesting. Thanks
Someone
for
else
that.
will have to do a talk next because that's empty my brain.